The goal of my language, the mission statement, if you will, basically take all of the babysitting pain, edge cases, common memory structures, data structures, and make it so the programmer doesn't have to think about that anymore. I've been doing some thinking, and some people are actually right. What I'm proposing is a high-level language, at least to some extent. The core of the language, the absolute basis, is fixed width types and pointers or memory addresses. So it's not that the entire language is supposed to be completely some kind of high-level magic thing. But yes, it is a high-level language beyond the availability of those low-level constructs that you can use to build a kernel. Now, when I say high level, what I mean is that you can still do the same basic stuff in this language that you could do in C, but for example, what you call structs, those don't exist because structs are honestly not a very good way of arranging memory. They're pretty much the anti-cache hit. And the truth is, if you need something as precise as a struct, what you really need is a memory map, and the language will support that. You know how if you type a memory map out in a text file, you'll be like 0x00 to 0x03, and then you give it the name of whatever's there, like riff header, because riff files are made up of chunks that start with a 4cc, and there are actually a lot of files that start with 4 letters as their header indicator, or file sections for that matter. But the idea basically is you have what you need if you have to go low level. You can do kernel stuff, but if you want to do a struct, what you really need to be doing is laying out exactly what you want in memory. You don't need to be doing one of the reasons that I'm bailing on C, which is fighting things like padding. You have to, add an attribute or a pragma or whatever to tell it, don't pad out this struct. I have it laid out exactly the way I want it. And you better hope to God that you didn't do something stupid like, say, put a machine with dependent value it gets run on a 32-bit machine, so now the memory map's off by 4 because you wrote it on a 64-bit machine. You see where I'm going with that. If you need the precision of a struct, you need to memory map out something in painstaking detail and manage it on a low level. But if you don't need that kind of nitpicky precision, most things can be composed of fixed width types and arrays of various types. Specifically, the only special type that I'm thinking of having as a sort of array is a string, but not just a string, but a list of strings, where the list is actually a list of offsets to strings in storage, such that you can reorder or delete or whatever by changing the actual offsets in the indirection list. But anyway, this is not the same thing as like a high-level language that's garbage collected and managed and all that, because you don't have something babysitting everything you do. You don't have something that occasionally just does a stop-the-world garbage sweep. What you have is, if you start a function and you allocate an array, and you use this array, at the end of that function, if it's local to the function, if you choose to make it local only to the function, it just gets destroyed. You don't have to free it. It just gets freed the second you walk away. Now, if you need something more permanent, you just make it global. And in fact, one of the things that I intend is to make everything global by default. Because the truth of a program is everything is global by default. Yes, I know, stack allocation, blah, blah, blah. But everything in a program is globally available, even if you're not supposed to globally touch it. There are a lot of things about modern programming languages that are basically lies on modern computers. So, for example, C, if you say that something is supposed to be a global variable, it's global. But if it's a local variable, it's still global. It's just that the compiler doesn't attempt to touch it directly globally, but it's still valid memory that the program can touch. So pretending like it's not global in any way is really just something to make the programmer feel better, more so than the actual underlying bare metal truth. And I was trying to think of how to explain my language, because so many people keep going, oh, this sounds like something where you have an AI neural compiler, or this sounds just like some other language, because they're trying to match features, or they're trying to match what they know about in their existing toolkit. And this is a paradigm shift, because the idea is you keep what low-level stuff you would need from C, but there are all these high-level constructs. Like, for example, linked lists are a terrible construct when it comes to actual performance. They're pretty good for a mental model, but they're terrible for performance. What my language would do is provide linked lists as just another implementation of arrays. And you notice everything ends up being built on arrays. So a linked list of just a single object, for example, all it would be is the offset to the next object and then the object. And instead of passing around pointers to disparate pieces of memory, you're passing around the offset within the array. And the compiler and the runtime handle things like, for example, if it's a resizable or growing array, then as you allocate more elements, edge cases like, well, we want to, we need to split this across these chunks, or, we have to jump across boundaries or whatever. Those are handled automatically by the code the compiler outputs and the runtime that checks all these values before it actually jumps in and does stuff. A lot of people are used to doing this manually in C. If you've ever written a memory allocator that allocates in large chunks and then has a pointer to the next chunk, and you just keep on, going to next, and that's how you make the array bigger so that you don't have to constantly do reallocate, which very often copies the entire array, taking massive amounts of time just to add another element or two or three or four. If you've ever written a chunking allocator and written algorithms to go through it, you know that you spend a lot of your time babysitting, hey, is this going to cross a boundary? The goal of my language, the mission statement, if you will, is to take all of the performance optimization pain and basically take all of the babysitting pain for edge cases and for common memory structures, data structures, and so on, and make it so the programmer doesn't have to think about that anymore. The compiler handles, is this going to overlap over a boundary? And if so, how many can we do before that? Let's do that number, then let's switch over across the boundary, then let's do the next number. The programmer doesn't have to babysit that anymore. So you can get all of these various data structures handled automatically under the hood, and you no longer have to write code to babysit it. You also no longer have to write painful, essentially assembly by some cryptic other terms, SIMD intrinsics. You don't have to do it because the language will do it. If you say, I have a structure, I'm not going to call them structures, with these things, like say file name, file size, file permissions, and type or whatever. The way it gets implemented under the hood is you have a data unit, and in that data unit you have data streams, and the streams are file name, file size, etc. And each one of those is an array, or in the case of file names, because it's a list of strings, it's an indirection block with a bunch of flat strings, and the indirection block points to the starts of the individual strings so that you can still use a fixed length offset to address variable length strings through the indirection block. And all the programmer has to do is go, okay, for file 0, open the file and, read the contents hash, whatever, or for file 0, look at the size, and if it's greater than X, open it, whatever. But as you go through this, open, do the whatever, if it's possible to fire off things in parallel, we would really rather have the compiler, and more importantly, the runtime, make the decisions about that based on what CPU you're targeting, or set of CPUs you're targeting, and what CPU you actually run the code on, because that's the hard part. There are so many different CPUs out there. Some have few execution units. Some have a lot of execution units. Some have in-order execution, you poor bastards. Some have out-of-order execution. Some have out-of-order with very large, powerful branch predictors. Some have out-of-order execution with extremely shallow branch predictors that if you mispredict, you cause a nasty pipeline flush that throws out, 10, 20, 30 cycles of work that were done up to that point, and it basically aborts, and the whole thing stops and waits for everything to start over. CPUs are complex, and basically they rewrite your code on the fly, and every CPU is a little different. So the goal is what we can know at compile time. We want to capture intent, not because of some AI crap, but you don't say, here's how you iterate through the array, by going, here's a pointer and add 1 to it at the end of every loop and blah, blah, blah. You say, I have an array type. I want to go through that array, and for every single element in that array, I want to do this, 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 and this. And the compiler can figure out what is dependent and what's not based on that. But modern compilers waste a ton of time trying to figure out what you were trying to do in the array instead of providing a mechanism for you to actually say, here is what I'm trying to do. You figure out the best way to do it. You kind of write pseudo-assembler in C, and I'm talking about taking that back to a more abstract way of saying it that gets boiled down into a concrete assembly level way of actually doing it. And of course, in classic me style, I managed to cut myself off with my fat finger hitting the button. I love phones, don't you? But yeah, I think I've said enough in this regard. I'm trying really hard to explain my idea, but the problem I ran into in the past several videos, and the reason that is so disheartening, is that everybody keeps just trying to shove it into a box they already fully understand without going, wait a minute, what if I throw out my assumptions and go back to how an actual CPU works? Does it make more sense from there? If you don't understand how a modern CPU works, the idea doesn't make sense. It's not C, it's not Rust, it's not Zig. No, I'm not going to try Fill C. No, I'm not going to try C3 or D or whatever. The whole point of this is that every language is pretending to just be C, but with some enhancement. Or like Rust is like, let's take sort of C, but bolt on a borrow checker. Pretend the programmer is an enemy. The point of my language is, let's take modern CPU design and use that as a template for a programming language design. You basically are, I hesitate to say this, but it's basically like a really, really fancy macro assembler. If you say you want to iterate over an array, the code for iterating over an array is basically the same no matter what for any given data type. Hell, it's not really even different for several different data types, except in the fact that you use a different mnemonic for it. So because we already know what that code should look like, code generation on my end is going to look a whole lot like we just take a block of code we already know and tweak it a bit to handle whatever the numbers are that we're running into. Like at runtime, we see an array is a certain length, and we go through it at that certain length. And if there's a faster way to do it for that length, we do it that way. But if there's not, then we don't. But it's not C. And no, people who are like, oh, you should just use C, you'll never get better than C, optimizing compilers, that's a sunk cost fallacy, and that's a familiarity bias. You've got to break out of that mental paradigm. If you understand how CPUs actually work on a low level, you'll understand that what C compilers do is like this black magic way of attempting to make C code by the standards that have been in place for years, for decades, fit the processor. I'm trying to write a new language that, rather than the language being designed and then being hammered to fit the processor, we use modern processors as the template for the language design, and then the structures and such that are derived from that logically are what the language actually provides and does. So it's completely flipping it. C was designed a long time ago basically to be what they called high-level assembly at the time. I don't want to make high-level assembly. I want to make something that can create assembly that is optimal and that doesn't make stupid edge case mistakes based on what the programmer says they're trying to accomplish. And if the programmer needs to be unsafe, if the programmer needs to do direct pointers, direct fixed width types, really low level stuff, they have the tools required for that. But we're not giving them things like structs. We're just not doing that kind of thing because it's this weird outdated notion. And a lot of the data types in C even are these weird outdated notions. We shouldn't be straying from what processors actually provide. C has become complex because the whole goal is we need to retain most of our compatibility with software from the 1970s, with systems from the 1970s, but we have all these modern changes, so we bolt on and bolt on and bolt on. It's like if you took a 1964.5 Mustang and you kept bolting stuff on top of it to try and keep it modern. I mean, can you imagine if someone had like the classic Japanese ricer style stuff bolted on top of a 1964.5 Mustang? You know, what if someone put like a turbocharged 4-cylinder in the front of it, or converted it into an EV? You know, what if they took the modern grill and put it on an ancient Mustang? It's so silly. At some point, you've got to throw out the baby and the bathwater and just start over. And that's the whole point. I think we're long overdue for a language reset. And that's why everybody keeps trying to drag it back to, well, this sounds like Java. This sounds like Erlang. This sounds like Haskell. This sounds like this other language. This has features from this other language. It's because they're not willing to think about any of the stuff I'm saying outside of, but this is the only way I understand programming. Look at some assembly code. Look at SIMD intrinsics. Look up execution ports. Look up modern CPUs, register renaming or register coloring. Understand how this stuff actually works, and you'll realize just how radically different C of today is from processors of today. And that's why you need stuff like LLVM that's all complicated and crazy and wacky and difficult and takes forever to compile stuff. My proposition is throw it all out and write something that's simpler, that makes more sense for modern stuff. But, you know, I get really angry when I make videos addressing people asking, why don't you just use C, or why don't you just use this other language? And the only responses I get are, well, but why don't you just use C? Well, you fucking moron, I just told you in the fucking video. Maybe pay some attention. Maybe actually listen to what I said. Don't come to me in a video where I answer the exact question you're asking, and then you ask me the same question. I'm going to think that you're absolutely stupid and don't qualify to continue surviving on this planet if you do stuff like that. Now, if you have a nuance, sure, that's different, that's fine. But if you ask me the question I just answered, you can go, all right? Just, you're wasting everyone's time. Please, if you don't want to actually think through, if you don't want to listen to everything I say to completion and actually think about it and actually talk about it, you know, in detail, in nuance, then please don't waste anyone's time repeating the same thing that you asked before, that someone else asked before, that I've already answered, that I literally put in the title that the video was there to answer. Okay? From now on, I am going to have to simply ban people from continuing to leave comments, or at a minimum, delete their comments, if this kind of brain-dead discussion continues. It's wasting everyone's time, and I don't like that. I want to respect the time of my viewers, and I'm trying to do something very serious here, despite the storage unit and car atmosphere. I'm trying to do something serious, and that's going to be a big deal if I can pull it off. And it's very unhelpful to have people saying, but why don't you just use C? Well, yeah, and like I like to say, why don't you just still use a horse and buggy, you know? Or, I don't know. Or why doesn't everyone ride a unicycle? Just take your stupid physical analogy. Pick any imperfect analogy you want that sounds dumb. That's kind of how I feel right now. I'm going to get off of here. I've got stuff to do. I don't have time for this anymore. But if you have genuine interest and questions, please don't hesitate to leave them in the comments. Take care.